Hello everybody, it's Amell, and today I'm going to show you how to solve the follow-up question to this problem, palindrome linked list. In the previous video, I showed you how to solve this problem using a stack data structure and the two-pointer technique. The time complexity was big O of n, and the space complexity was also big O of n. But this time, the follow-up question says, could you do it in big O of n time and big O of 1 space? So this time, we're not going to use a stack. We are going to modify the pointers in place. So we're going to modify the second half of the list and have a pointer at the beginning of the first half and a pointer at the beginning of the second half and compare as we go. If we find that the corresponding node in the first half doesn't match the corresponding node in the second half, we know that this is not a palindrome and we can return false immediately. So that's the main idea here. We're going to modify the pointers and then check as we go. So the space complexity is going to be big O of 1 because we're not going to be using a stack or any other data structure. The time complexity will be big O of n. So without further ado, I'm going to show you how to write the code. First, if head equals null or head.next equals null, return true. That means if the list is empty or if there's only one node in the list, that means that yes, this is a palindrome. Then I'm gonna have my two pointers pointing to node slow initially points to the head, and pointing to node fast also points to what the head is pointing to. Then I'm gonna say I'm gonna move slow one step at a time, and fast I'm gonna move it 2 steps at a time. And I want that by the end of the iteration, I want slow to be at this position. In this example, slow will be here, and then I can reverse this part by modifying this link to point to the next node of 1, and then I can move the 1 at the beginning. That's why I want to be slow. That's why I want slow to be there, because I want to be able to get this node and put it in here after slow. So I'm gonna do while fast.next is not equal to null and fast.next is not equal to null. I'm gonna say slow gets the value of slow.next and fast gets the value of fast.next. Alright, so now slow will be here, and I want to reverse this part. So I'm going to have pointing to node last points to whatever slow.next is pointing to. So last is pointing here, and slow is pointing here. So I'm going to have while last.next is not equal to null. As long as I have a next node to consider, I'm going to move that node at the front, and that's going to allow me to reverse this part of the list. So I'm going to say pointing to node temp points to whatever last.next is pointing to. So that would be that TMP is this one in this example. So slow is here, last is here now, and TMP is this one. So now I want to move last.next, instead of pointing here, I want this to point to the next node, to null. So I'm going to say last.next points to whatever tmp.next is pointing to. And then I want to move this one and put it in front of slow. So I'm going to say tmp.next points to whatever slow.next is pointing to. So now the one.next is pointing to slow.next. That would be here. And then I need to say that slow.next points to the 1. And that's gonna allow me to reverse the second half. And now that it is reversed, I can have a pointer at the beginning. I'm gonna call it pre, and then I can say while slow.next is not equal to null. Then slow is here, but I want to start in the second half, so I'm going to move slow by 1. slow gets the value slow.next. And then I want to compare the corresponding node in the second half with the corresponding node in the first. If pre.value is not equal to slow.value, return false. If the values don't match, this is not a palindrome, so I'm done. And pre gets the value of pre.next. And if I was able to pass all the checks, then at the end I return true, because this is a palindrome. So I'm going to run the code. It seems to be working fine. Submit a solution. Alright, this is working perfectly. 1 millisecond faster to 96.60% of Java Online submissions. So please press the like button, don't forget to subscribe, and see you next time.